So I'm here at the European Geosciences Union Conference in beautiful Vienna on a beautiful day with Christian Koeberl, who is a planetary scientist, geochemist, and Earth impact researcher. And he's very passionate about his area of interest, and this is a full-time pursuit for, I guess, for the past few decades. And Christian, you were telling me in our interview just now that up until 1980, Earth impact research was really non existent. That it wasn't until the late 70s, and well, until we got the first samples back from the moon, that geologists at least recognized that the craters on the moon were caused by impacts and not volcanism. Is that correct?
So the problem is that over hundreds of years since craters on the moon were discovered by Galileo in 1610, the geologists on Earth were going by what they know, basically, what is happening on Earth. And they were looking around and they were seeing crater-like features, mostly being formed by volcanism. And so therefore the interpretation was, not totally unlogically, that the craters on the moon might also have formed by volcanism. Impact as a geological process was not really known at that time, and it only started during the 20th century that some people thought, well, maybe if a meteorite falls on Earth, it might make a crater. And initially, at the beginning of the 20th century, they thought it's a large asteroid, a large meteorite falls on Earth and makes a small crater. And it took basically until the 1970s when it started, right after the first lunar samples came back, and then the 1980s when the evidence for the dinosaur-killing impactor was discovered, that geologists made also some experiments and realized that all you need is a very small object that makes a crater that is at least 20 times in diameter larger than the impacting body. And therefore, you don't need a big meteorite to make a crater. You need a small asteroid to make a big crater. And this is kind of the time when impact started to become known by geologists in general, because first they were going by what they see on Earth, and there is not too many impact craters that have been preserved. And the craters on the moon, we only really knew for sure that they formed by impact when the first samples were brought back by the Apollo missions back to Earth and studied. So it is basically people realize then that impact is actually an important geological process, and this is new research that happened on Earth over the past, I would say, 3, 4 decades. And this is about as long as I've been studying craters on Earth.
But there's no periodicity in the Earth cratering record. There's some researchers who are respected in their field who do think there's a periodicity, but you do not agree there's a periodicity in the impact record that we identified.
I look at the number of craters that we have on Earth that are identified unambiguously as impact craters. There's about 200 of them. And less than half of those actually have precisely determined ages. So the number of impact structures above a certain diameter too, because small objects, they are coming from the neighborhood, and it's not anything that would be caused by anything that would say periodicity, because this is what people mean is large impacts, and we simply don't have enough of those. We have a handful of craters when we know in precise ages, and this is just too small a number to determine with any unambiguity any periodicity, so no.
And the oldest impact craters that we've identified only date back to 2.5 billion years ago, considering our planet is 4.5 billion years old almost. So we really have a hard time identifying the oldest craters because of the weathering and the climate has covered them over or changed their and also the movement of the continents. It's a real challenge.
You summarize it well, yeah.
It's a real challenge, and the only way you can identify these craters is through impact shocks on the rocks themselves, correct? It's like, because you said the Earth impactors, these high velocity impactors, are even more uh, they're even more impactful or detrimental with more kinetic energy than any sort of volcanism or earthquakes or anything like that. Is that correct? Did I misunderstand you?
You got it about right. Yeah. So impacts are per unit area about somewhere between 100 to 10,000 times more energetic than any volcanic process on Earth. And these impacts, because of the high energy of the explosion, cause a lot of changes in the structures of minerals. And these structures can be determined. They form only by the shock features. And this is what we can uniquely identify as of impact origin. The same thing happens, a small contamination of extraterrestrial material that is clearly identified as extraterrestrial, which can be done by geochemical and isotopic studies, can also show us that the particular structures of impact origin. And yes, the oldest impact structures we have identified on Earth are about 2.2 to 2.3 billion years old, and there are only three that are known of that age range. So before that, about half the age of the Earth, we have no proper impact crater record left. We have a few spheral layers that are of impact origin that go up to about 3.5 billion years age, and that's about it.
And 2029, the UN has denoted that as the planetary defense year, the year of planetary defense. And I believe you were involved with this initiative.
Yes. A few months ago, the United Nations, the General Assembly, declared that 2029 will be the International Year of Asteroid Awareness and Planetary Defense, basically trying to make the concept that asteroids might actually even pose some danger to the surface of the Earth, even a small impact, even a 50-meter diameter object, if it hits a large city, for example, could easily kill 1 million people. So that would be a very negative effect indeed, you know. And so that would tell us that impacts are, of course, something that didn't only happen in the geological past, but can also happen in the future.
And now we know of 40,000 near Earth asteroids, you say?
We currently know 40,000 or so Earth crossing or near Earth asteroids. Only 20 years ago, we only knew about 1,000, and the number of new asteroids that are discovered is going up, up, up. Every year, we know hundreds to even thousands more.
And so you think maybe in 10 years' time we'll know maybe as many as 100,000.
Probably, yeah.
And and time is not on our side.
Nope.
Well, thank you so much,
Okay.
Christian, for your time today.
Sure.